Suppose we want to evaluate the following limit. Limit of x squared minus x minus 6 over x minus 3 as x approaches 3. Here we have a rational function. If some of you don't know what is a rational function is a fraction such that both the numerator and the denominator are polynomials. Anyway, we want to find the limit of this fraction, this function, as x approaches 3. If you remember from our previous videos, the first thing, almost always, you should try to find the limit of any function is to plug in and see if you get a number. So let's plug in 3 everywhere x appears and see what happens. If we plug in 3, we get 3 squared minus 3 minus 6 over 3 minus 3. 3 squared is 9, so we have 9 minus 3 minus 6 over 3 minus 3. 9 minus 3 minus 6 is 0, 3 minus 3 is 0, so we have 0 over 0. We did not get a number, we got 0 over 0. And this is the most common indeterminate form. It is called an indeterminate form because you cannot from the form alone determine the value of the limit. When you try to evaluate a limit of a rational function by direct substitution and encounter to this form, you can conclude that the numerator and the denominator have a common factor. After factoring and dividing out, you should try direct substitution again. Let's review this technique. By direct substitution, both the numerator and the denominator are 0 when x equals 3. So plugging will not yield the value of the limit. To find the limit, we should factor the numerator and the denominator, divide out any common factors, and then try plugging again. This procedure for evaluating the limit of rational functions is called the dividing out technique. Before we jump and find the limit of this function with the described technique, maybe it's not a bad idea to see the graph of this function and see what is the limit of this function as x approaches 3. Here you can see graph of our function. This is a sample point on the graph of our function. The coordinate of this point is 2 and 4. If we plug in 2 in this function, the corresponding y value of the function will be equal to 4. 2 squared minus 2 minus 6 is equal to negative 4. 2 minus 3 equals negative 1. Negative 4 over negative 1 equals 4. So this is a sample point on the graph of the function, and this is the coordinate of this point. Now attention to the coordinate of this point as this point moves to the x equals 3. As x approaches to 3, attention to the y coordinate of this point. For example, when x is equal to 2.9, the corresponding y value of the function is 4.9. Let's continue and get closer to x equals 3. As you can see, when x is very close to 3, the corresponding y value of the function is 4.99, which is very close to 5. So we can guess that the limit of this function as x approaches 3 should be 5. Before we back to our question, as you can see, when x approaches to 3 from the right, now the value of x is a little greater than 3. The corresponding y value is very close to 5 also. So the left limit and right limit of the function as x approaches 3 equals 5. From the graph of this function, we see that the limit of the function as x approaches 3 equals 5. Now let's find the limit of the function with the dividing out technique. The first step is to factor numerator and the denominator. If we factor numerator, we have x minus 3 times x plus 2. In the denominator, we have x minus 3, which is a simple expression and we can factor it. The next step is to cancel the common factor between numerator and the denominator. And of course, the common factor is x minus 3. If we cancel x minus 3 from the top and the bottom, we get limit of x plus 2 as x approaches 3. To evaluate this limit, we substitute 3 for x and we have 3 plus 2. 3 plus 2 equals 5. So the value of the limit of this function as x approaches 3 equals 5. Let's try another example. Limit of x squared plus 2x minus 8 over 2x plus 8 as x approaches to negative 4. As usual, the first step is to plug in negative 4 to see what happens if we plug in the number itself in the function. If we plug in negative 4 everywhere x appears, we get negative 4 squared plus 2 times negative 4 minus 8 over 2 times negative 4 plus 8. Negative 4 squared equals 16. 2 times negative 4 equals negative 8. 2 times negative 4 again is negative 8. So we have 16 minus 8 over negative 8 plus 8. 16 minus 8 equals 0. Negative 8 plus 8 is also 0. So we have 0 over 0. Because our function is a rational function, and after direct substitution, we get to 0 over 0, so we can apply dividing out technique for this example also. The first step is to factor numerator and the denominator again. If we factor numerator, we have x plus 4 times x minus 2 in top. In the bottom, we can factor 2 from the denominator, and then we have 2 times x plus 4. The next step is to cancel the common factor between numerator and the denominator. If you pay attention, the common factor is of course x plus 4. If we cancel x plus 4 from the numerator and the denominator, we get to limit of x minus 2 over 2 as x approaches negative 4. And to evaluate this limit, we plug in negative 4 for x and we have negative 4 minus 2 over 2. Negative 4 minus 2 equals negative 6. Negative 6 over 2 equals negative 3. So the limit of our function as x approaches negative 4 equals negative 3. Before we jump to the next example, let's recall two identities. The first identity is x cubed plus y cubed equals x plus y times x squared minus xy plus y squared. And the next identity is x cubed minus y cubed equals x minus y times x squared plus xy plus y squared. Usually, students do not recall these two identities because rarely we use them to factor polynomials. Suppose we want to factor x cubed minus 8. If you compare this expression with the second identity, which is something cubed minus something else cubed, instead of x cubed, we have exactly x cubed. But instead of y cubed, we have 8. So first, we should rewrite 8 as 2 to the third. Note that 2 cubed, 2 times 2 times 2 equals exactly 8. So first, we rewrite our expression in the form of our identity. And then we follow the pattern of the identity and easily we can factor our expression. According to the pattern, in the first bracket we have x minus y. So in our example we have x minus 2, because instead of y we have 2. Instead of the second bracket we have x squared plus, instead of x times y we have x times 2, and instead of y squared we have 2 to the 2. Because again, note that instead of y, everywhere you see y, you should replace it with 2. Everywhere y appears in our identity, instead of y we replace it with 2. So we have x minus 2 times x squared plus x times 2 plus 2 squared. And if we simplify the second bracket, we can rewrite our answer as x minus 2 times x squared plus 2x. X times 2 is exactly 2x, and 2 squared equals 4. Let's factor another expression. We want to factor a cubed plus 1 under 25. Instead of x cubed, we have a cubed. So x is replaced by a. So everywhere we see x in our identity, we should replace it with a. And instead of y cubed, we have 125. We can rewrite 125 as 5 to the third. Note that 5 to the third is 5 times 5 times 5. 5 times 5 times 5 equals 125. So the first step is to rewrite our expression in the identity form, in the form of the left side of the identity, and then follow the pattern of the identity. According to the pattern of our identity, a cubed plus 5 cubed equals a plus 5 times a squared minus a times 5 plus 5 squared. If we simplify the second bracket, we can rewrite it as a squared minus 5a plus 25. I hope this review was helpful for you. Remember factoring sums and differences of cubes. What is the limit of x cubed minus 8 over x squared minus x minus 2 as x approaches 2? As usual, the first step to find this limit is to plug in 2 everywhere x appears. If we plug in 2, we have 2 cubed minus 8 over 2 squared minus 2 minus 2. 2 cubed is 8 minus 8 over 2 squared is 4. 4 minus 2 minus 2. 8 minus 8 equals 0. 4 minus 2 minus 2 equals 0. So we get 0 over 0. Because when we replaced our constant in our function and we get to 0 over 0, we should factor numerator and denominator to cancel the common factor from numerator and the denominator. According to the identity that we reviewed, x cubed minus 8 can be rewritten as x minus 2 times x squared plus 2x plus 4, and x squared minus x minus 2 is a quadratic form. We easily can factor it and rewrite it as x minus 2 times x plus 1. The common factor is x minus 2 if we cancel the common factor from the top and from the bottom. We have x squared plus 2x plus 4 in top, x plus 1 in bottom. If we replace 2 everywhere again, x appears. We have f4 plus 4 plus 4 in top over 2 plus 1. Note that 2 squared is 4, 2 times 2 is 4. So we get to 12 over 3, which is equal to 4. So the limit of this function as x approaches 2 equals 4. Before I finish this video, let me pay your attention to something important about the common factor. Let's start with the first example of this video. In this limit, x approaches 3, and the common factor that was cancelled from numerator and the denominator was x minus 3. In general, as x approaches a, the common factor between numerator and the denominator is x minus a. So always remember this note. As x approaches a, the common factor is x minus a. This factor is the reason that when we plug in a in our limit, we get to 0 over 0. And by cancelling this common factor from numerator and the denominator, we can find the limit. So again, as x approaches a, the common factor is x minus a. For example, when x approaches 2, the common factor is x minus 2. As x approaches negative 1, the common factor is x minus negative 1 or x plus 1. For example, can you guess what is the common factor that will be cancelled in this question? Note that x approaches to negative 4. So the common factor is x plus 4. Note that x approaches to negative 4. And the common factor is x minus negative 4, which is equal to x plus 4. And in this example, of course, the common factor is x minus 1. As x approaches 1, the common factor is x minus 1. As you can see, the common factor between numerator and the denominator is x minus 1. And at last, in this example, because x approaches 2, the common factor should be x minus 2. As you can see, the common factor between numerator and the denominator is x minus 2. So this trick can be very helpful in factoring numerator and the denominator of rational functions.